Hello everyone, this is Sravanthi, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today we are going to discuss about potable water, what are the steps involved in this treatment of potable water, and what is disinfection and disinfection of water by chlorination and ozonization. So what is potable water? What are the specifications of potable water? So generally potable water means water which are free from contaminants. Water is free from contaminants or water is safe for human consumption is called potable water. Generally called drinking water. So water is free from contaminants which is used for human consumption is called potable water. So according to WHO, World Health Organization and Indian Council of Medical Research. According to WHO, World Health Organization and Indian Council of Medical Research, the water should be clear, colorless, odorless, and it should be cool and pleasant taste. And it should be free from harmful gases or harmful bacteria or just suspended impurities. And also it should be free from dissolved gases like carbon dioxide, hydrogen sulfide, ammonia, etc. And the total hardness should be less than 500 ppm and chloride content should be less than 250 ppm and fluoride content should be less than 1.5 ppm and total dissolved salts less than 500 ppm. And the potable water pH ranges it should be 6.5 to 8.5. So this water is considered as potable water. So potable water means generally raw water after treatment will get drinking domestic usage water. So water is which is free from all the contaminants or water that is used for human consumption. So that water is called potable water. So what is the specification of potable water? According to World Health Organization and Indian Council of Medical Research, the water should be clear, colorless, odorless, and it should be cool and pleasant taste. And it should be free from dissolved gases, harmful bacteria or impurities or any suspended impurities present in water. And the hardness should be less than 500 ppm. A total dissolved gas is less than 500 ppm. And chloride content is less than 250 ppm. And fluoride content is less than 1.5 ppm. And pH range of this water is 6.5 to 8.5. So this water is considered as potable water. So raw water after treatment will get drinking water or domestic usage water is called as potable water which is free from all the bacteria which is used for human consumption is called potable water. So what are the steps involved in this treatment of potable water? Generally main source of water is rivers, lakes, ponds, etc. So this water is containing so many impurities, colloidal impurities, floating materials or suspended impurities, so many impurities containing. So generally this water collected by municipalities for our domestic usage purpose they are supplying. But before that the purification is most important because this water contains so many impurities like suspended impurities or colloidal impurities or harmful pathogenic bacteria, etc. So before the supply, they have purified this water. So that is called treatment of potable water. So what are the steps involved in this treatment of potable water? Main thing is the source of water is rivers, lakes, etc. The main source of water is rivers, lakes, ponds, etc. So these are containing so many impurities like floating materials, wood pieces, leaves, papers, or any suspended impurities or colloidal impurities present in this water. So this water generally collected by municipalities which they are supplied for our domestic usage purpose. So before the supply, they have to purify all these impurities in this water. So here it's involved in total 6 steps. First step is screening. Screening, aeration, sedimentation, coagulation, filtration and disinfection. Total 6 steps involved in this treatment of potable water. So what is the meaning of screening? So you see, this is raw water passed through the screeners. So in this case, wood pieces or any other floating materials present in this all are separated when we pass it through the screeners. So coagulation, sedimentation, filtration, disinfection. So after completing this step, it is stored in the storage tank and they are supplied to for our domestic usage purpose. So these are the steps involved in this treatment of potable water. So first step is screening. So the water, this collecting water is raw water passed through the large screeners. That means the screeners containing large number of holes. So it retains floating impurities like wood pieces, leaves or any heavier objectives present in this water. All are separated when we pass it through this screeners. So the screeners containing large number of holes. So in this case, it can be removed all floating materials, wood pieces, leaves, heavy objects, etc. all are removed when we pass it through these screeners. Next, second step is aeration. The mixing of air or air is passed through this water or otherwise water reacts with air. So in this case, the water is then subjected to aeration. Aeration means reacting with air. Reacting with air. So in this case, which helps to in exchange of gases between water and air. When we pass air through this water, so in this case it exchanges between water and air. So in this case, increase the amount of oxygen content also. So in this process, when we pass oxygen or air through this water, so in this case oxygen percentage increases and also removes the impurities like iron, manganese, dissolved gases like H2S, carbon dioxide or ammonia, etc. So in this step 1 screening, when we pass this water is passed through the screeners, in this case all the floating materials, wood pieces, heavy objects, etc. we can remove in this step 1. So after that, aeration means mixing of air. The water reacts with air. So in this case, oxygen percentage also increases and it removes the impurities like iron, manganese, okay, and also removes dissolved gases like hydrogen sulfide, carbon dioxide and ammonia. Next, step 3, sedimentation. So in this process, this water is passed through the large stable tank. Large stable tank. Do not disturb for 2 to 3 hours. So in this case, all the suspended particles which are present in water, all are settled down at bottom of this tank. This is called sedimentation. All the particles, suspended particles settle at the bottom of the tank due to gravity. This process is called sedimentation. So here, in this process, water is allowed to stand for 2 to 6 hours without any disturbance. So here, for example, water is taken in this tank and do not disturb for 2 to 3 hours. So in this case, all the suspended impurities, but in this process, we can remove only 75% of impurities. Only 75% of suspended and colloidal impurities are settled down at bottom of this tank due to gravitational force. Due to gravitational force. Starting here, water is passed through this large stable tank and do not disturb for here 2 to 3 hours. So in this case, all the colloidal impurities or suspended impurities, only 75% of these suspended and colloidal impurities settle down at the bottom of this tank due to gravitational force. So this process is called sedimentation. And next, fourth one is coagulation. Coagulation means we are adding some coagulants like alums, aluminum sulfate or sodium aluminates. So you see coagulants like alum, sodium aluminate and aluminum sulfate added to this water. So when we are adding these coagulants in this water, it forms flocks, the precipitates. That means called flocks. This flocks attracts or observes or accumulation of colloidal particles. It observes colloidal particles. The resulting is setting of the colloidal particles at the down of this tank. This is called coagulation. In sedimentation process, we can remove only 75% of colloidal impurities. So remaining 25% of impurities we can remove by adding coagulants in this water. Coagulants means here we are using chemicals are alums, aluminum sulfate or sodium aluminate added to water. So in this case it forms flocks. So these are called flocks. These flocks are absorbed, which are the colloidal impurities present in this water and accumulate, form, precipitate and settle down at this bottom of this tank by adding coagulants. So that's why this process is called coagulation. Next, filtration. So filtration means you can remove all the impurities present in water. It helps to removal of the colloidal and suspended impurities which are not removed by sedimentation method or coagulation method, which are removed, which we cannot remove by that process. So the remaining impurities or any other colloidal impurities we can remove by using this filtration method. So generally in this filtration purpose, we can use sand filters. Sand filters are employed for this filtration process. So in this case, in this filtration, fine sand layer on the top of supported by this coarse and sand layer which is supported by gravel. For example, here see this sand filter. When the raw water passed in this filters, so it containing sand bed. That means sand bed means sand layers, coarse layers, gravel layers, different layers present in this filter. So when we pass this raw water in this sand filters, so all the suspended impurities or colloidal impurities which are present in water, all are absorbed by these filters. Then finally, outlet water, it is free from all the colloidal impurities. So this method is called filtration process. And final step is disinfection of water by sterilization. So here disinfection or sterilization means removal of complete 100% of bacteria. Removal of or kill the bacteria. To remove 100% bacteria, destroy the harmful bacteria which are present in water. So this is called disinfection and also called as sterilization. So this disinfection of water by using two types of chemical. Disinfection purpose we are using two chemicals. One is ozone and the one is chlorine. If in case we are using ozone, this process is called disinfection of water by ozonization. Disinfection of water by ozonization. If in case remove the bacteria or disinfection purpose we are using chlorine, so this is called disinfection of water by chlorination method. So total involves 6 steps in this treatment of potable water. All the 6 steps we can remove all the impurities present in water. So in this screening we can remove only floating materials, wood pieces, heavy objects, etc. And second one is aeration, reacts with air. So in this case it increases the oxygen percentage and remove the metals like iron, manganese, etc. And also remove the gases like carbon dioxide, hydrogen sulfide, etc. All the suspended gases which are present in water, all are removed by adding air in this water. Next, third step is sedimentation. In the sedimentation process we can remove 75% of colloidal impurities or suspended impurities. Remaining 25% of impurities we can remove by adding coagulants. Coagulants means like alums, aluminum sulfate, sodium aluminate, etc. added. For what purpose? So which are removed in the sedimentation process. The remaining colloidal impurities we can remove by adding coagulant method. And fifth one is filtration. So in this filtration process, which are not we cannot remove by this coagulation method or sedimentation method. So remaining impurities we can remove by using this filtration method. So that purpose it employed sand filters we can use here to remove of all the colloidal suspended impurities present in water. And finally disinfection. Disinfection means we can remove 100% of bacteria to kill the bacteria by adding disinfectants. Generally, this disinfection purpose, we are using two different types of disinfectant. One is ozone and the one is chlorine. If in case we are adding ozone, this process is called disinfection of water by ozonization. If in case we are adding chlorine, in this case, this process is called disinfection of water by chlorination method. This is the treatment of potable water. Now discuss disinfection of water by ozonization. So disinfection of water by ozonization. So already we know that ozone is the powerful disinfectant. Ozone is the powerful disinfectant, but it is readily absorbed by water. Ozone is a powerful disinfectant and readily absorbed by water. The ozone is highly unstable. But ozone is highly unstable. So it breaks down to give nascent oxygen. Ozone is the powerful disinfectant and readily absorbed by water. But it is highly unstable. So it is easily decomposed into oxygen and nascent oxygen. So you see the reaction. Ozone, it is highly unstable. So it gives oxygen and nascent oxygen. So this nascent oxygen is the most powerful disinfectant than ozone. So this nascent oxygen reacts with bacteria which are present in water and kill the bacteria. It is most powerful disinfectant than ozone. But what is the disadvantage of ozone or ozonization? This process is costly and cannot be used for large scale. It cannot be used for large scale due to unstable of ozone. Already we know that ozone is highly unstable. So we cannot be used for storage of long period, long time. We cannot store this ozone. Next, second one is by chlorination, disinfection of water by chlorination method. So chlorine generally we are used in this, we are added in this water to removal of bacteria which are present in water. So if in case we are adding chlorine in the form of chlorine gas, chloramine combination or bleaching powder, any form we are added chlorine in this water, it reacts with bacteria and kills the bacteria. So this process is called disinfection of water by chlorination method. So if in case, for example, chlorine added in the form of gas, the chlorine gas added in this water. So here chlorine gas is a very good disinfectant. Chlorine gas is the very good disinfectant which can be bubbled in the water. So in this process, calculated amount of chlorine gas is passed in order to destroy the pathogenic bacteria. When we pass a certain amount of chlorine in water, it destroys the pathogenic bacteria or harmful bacteria which are present in water. So that is called disinfection of water by chlorination method. So chlorine is also reacts with water and generates hypochlorous acid. Chlorine is also reacts with water and generates hypochlorous acid and also produces nascent oxygen, which is powerful oxidizing agent and kills the bacteria. For example, here chlorine, here we are adding chlorine in the form of gaseous chlorine gas. So when we are adding chlorine gas in this water, it produces first hypochlorous acid. Formula is HOCl. It produces hypochlorous acid and byproduct is HCl. So this hypochlorous acid further decomposed into HCl and nascent oxygen. So if you are adding chlorine in the form of gas, chlorine gas added in this water, it produces hypochlorous acid as well as nascent oxygen. So this nascent oxygen and hypochlorous acid both are powerful disinfectant and reacts with bacteria and kill the bacteria. For example, chlorine added in the form of chloramine combination. Chlorine added in the form of chloramine combination. For example, in chlorine here, chlorine and ammonia both are taken in this 2:1 ratio. Chlorine and ammonia both are taken in this 2:1 ratio. So in this case, it forms chloramine. It forms chloramine. So here, chlorine and ammonia both are taken in this 2:1 ratio. Then it produces chloramine. This chloramine reacts with water, then produces ammonia and main product is hypochlorous acid. If in case chlorine added in the form of chloramine combination, so here chlorine and ammonia both are taken 2:1 ratio are added in this water. So chlorine and ammonia combine to form chloramine. So this chloramine reacts with water then produces hypochlorous acid. So we know that hypochlorous acid acts as a powerful disinfectant. So it reacts with bacteria and kill the bacteria. Or otherwise hypochlorous acid decomposed into HCl and nascent oxygen. This nascent oxygen also will know that powerful disinfectant than ozone. So this hypochlorous acid and nascent oxygen reacts with bacteria which are present in water, then kill the bacteria. And finally, by adding bleaching powder, if in case chloride added in the form of bleaching powder formula CaOCl2. Hypochlorous acid. In this case also when we are added bleaching powder, calcium hypochloride CaOCl2. So in this case, this calcium hypochloride reacts with water. When we are adding bleaching powder or chlorine added in the form of bleaching powder in water, it produces calcium hydroxide and chlorine. So this chlorine reacts with water, then gives hypochlorous acid. So this hypochlorous acid reacts with bacteria and kill the bacteria. Or otherwise this hypochlorous acid undergoes decomposition, then gives nascent oxygen also. So if any case we are adding chlorine in the form of chlorine gas, chloramine and bleaching powder, finally it produces hypochlorous acid or nascent oxygen. Hypochlorous acid and nascent oxygen. So this hypochlorous acid and nascent oxygen both are acts as a powerful disinfectant, and this reacts with the bacteria which are present in water and finally kill the bacteria. So this is called disinfection of water by chlorination method. Now let's discuss breakpoint chlorination. So what is the meaning of breakpoint chlorination? Generally, we are added chlorine in water to remove impurities, to remove or kill the bacteria which are present in water. Generally, which type of bacteria or impurities present in water? So, water containing bacteria or organic impurities, reducing substances and free ammonia. For example, this type of impurity present in water. So when we are adding chlorine water, it reacts with all these type of bacteria and remove the bacteria or remove the impurities present in water. So at which point chlorine removes all the impurities which are present in water, that point is considered as breakpoint chlorination. That point is considered as breakpoint chlorination. For example, here in this water it containing the following impurities like bacteria, organic impurities, reducing substances, free ammonia, etc. So we can remove all the impurities by adding chlorine. So here in this process, chlorine may be added to water directly as a gas or chloramine or bleaching powder. So in this case, when we are adding chlorine in the form of, for example, a bleaching powder or chlorine gas, when chlorine is applied to water, the results obtained can be depicted graphically in the graph. So when we are added in the water, chlorine added in the water, so what is the results and how can we remove all the impurities present in water? It can show this by the graph. So the graph shows the relationship between the amount of chlorine added to water and residual chlorine. So this graph mainly explains the relationship between the amount of chlorine added in this water and residual chlorine also present in this water. So added chlorine is externally added chlorine in this water. Residual chlorine is unreacted chlorine. This, for example, we are adding some amount of chlorine in this water, that is called applied chlorine. So in this case, few percentage of chlorine reacts with water, that is addition chlorine, and unreacted chlorine also present in this water, that is called residual chlorine. See here in this graph clearly explains the relationship between applied chlorine or added chlorine in water and residual chlorine also present in this water. For example, here x-axis we are taking applied chlorine and externally added chlorine in this water. Externally added chlorine in this water. In y-axis we are taking residual chlorine. Residual chlorine is unreacted chlorine present in this water. So first we are added few percentage of chlorine in this water. Here, what is the reaction? There is no residual chlorine here. There is no residual chlorine. That means how much percentage of chlorine we added? It totally reacts with bacteria. It reacts with bacteria. And second, again we increase the percentage of applied chlorine here. Again increase the percentage of applied chlorine. Here residual chlorine percentage also increases. That means unreacted chlorine also present in this. And again increase the percentage of applied chlorine. Here slightly this residual chlorine percentage decreases and few percent reacts with bacteria and kill the bacteria. And again increase the percentage of chlorine. There is only residual chlorine is there. That means it completely remove all the bacteria which are present in water. So at which point chlorine completely removes all the bacteria which are present in water, that point is considered as breakpoint chlorination. That means it's present only residual chlorine. That point is considered as breakpoint chlorination. So see here, for example, in this graph, initially the applied chlorine is used. Initially the applied chlorine is used to, for what purpose we added chlorine in this water? To kill the bacteria. To kill the bacteria. For example here, when we are adding applied chlorine, so what purpose we are using this applied chlorine? It is used to kill the bacteria and also oxidizes all the reducing substances present in water. So for example here, see the graph. Starting we are added in this applied chlorine here. For example here we are adding 2% of chlorine in this water. Here see, x-axis we are taking applied chlorine and externally added chlorine. Y-axis we are taking residual chlorine. Residual chlorine means unreacted chlorine present in water. In x-axis applied chlorine means externally added chlorine. For what purpose we are added this chlorine in this water? To remove harmful bacteria or any other impurities present in water. That purpose we are added chlorine in water in the form of chlorine gas or chloramine or bleaching powder. In any way we are added in this chlorine, it produces hypochlorous acid or nascent oxygen. These two are acts as most powerful disinfectants and it reacts with bacteria and kill the bacteria. So how to kill this all the bacteria or impurities present in water? It is clearly shown in this graph. For example, starting we are adding 2% of chlorine, for example, or few percentage of chlorine added in this water. So here there is no residual chlorine. That means it kills the bacteria and oxidizes all the reducing substances. So starting we are adding, for example, 2% of applied chlorine in this water. So there is no residual chlorine. That means it's zero. And it removes the bacteria present in water and oxidizes all the reducing substances which are present in water. This is first one. And again increase the percentage of chlorine. For example, 4% here we are adding. So in this case, residual chlorine percentage also increases. So what is the meaning here? As the amount of applied chlorine increases, the amount of combined residual chlorine also increases. Combined residual chlorine also increases. This is due to the formation of chloramine and other chloro compounds. Again increase the percentage of chlorine in this water. So what are the reactions takes place? Residual chlorine percentage increases and also formation of chloramine and chloro compounds. And again increase the percentage of applied chlorine. So in this case, destruction of all chloramine compounds or any other impurities present in water, and here slightly decreases the residual chlorine. And again increase the percentage of chlorine, applied chlorine. So here only is present residual chlorine. So here at one point in further chlorination, the oxidation of chloramines and other impurities starts and there is fall in the combined chlorine content here. And next is the combined residual chlorine decreases to minimum point. The combined residual chlorine decreases to minimum point at which oxidation of chloramines and other impurities complete and free residual chlorine begins to appears. So this minimum point is known as breakpoint chlorination. So at which point chlorine completely removes all the impurities present in water and it gives good taste odor to water. That point is considered as breakpoint chlorination. So what are the advantages of breakpoint chlorination? So it removes bad taste. It removes bad taste, color, or oxidizes completely organic compounds, ammonia, and other reducing impurities. It removes bad taste, odor, and oxidizes completely all the organic compounds present in water, and also it removes ammonia and other reducing impurities. It destroys completely 100% all disease producing bacteria. It removes all 100% disease producing bacteria which are present in water, and it prevents growth of any weeds in water. And say plants, small plants which are present in water, weeds, that is called weeds. So it prevents growth of any weeds present in water. So these are the advantages of breakpoint chlorination. So in this class, we discussed already what is potable water. So what is the meaning of potable water? Which is free from all the harmful bacteria present in water, which is useful for domestic usage purpose or human consumption. That water is considered as potable water. Simply we say domestic usage water. So source of water is rivers or lakes, etc. But containing so many impurities. So before supply this water, the treatment is most important. They have to treat this water. So in this treatment of potable water, it's involved total 6 steps: screening, aeration, sedimentation, coagulation, filtration, disinfection. So after purifying, we are using for drinking purpose and domestic usage purpose, human consumption purpose, we supply this water. So in this disinfection, mainly disinfection of water by ozonization and chlorination. So ozonization means when we are adding ozone in this water, it produces nascent oxygen. It's the most powerful disinfectant. And if in case we are adding chlorine in the form of chlorine gas, bleaching powder or chloramine combination, so in this case also it produces hypochlorous acid and nascent oxygen. So both are acts as a powerful disinfectant and reacts with bacteria and kill the bacteria. So at which point chlorine completely removes all the bacteria present in water and produces good taste or odor to water. That point is considered as breakpoint chlorination. It is clearly explained by this graph. I hope understand all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.